Okay.
Hello, Simon.
Can you hear me?
Yes, we hear you.
Okay, great. So I'm going to share my screen.
Yeah. So how are you today?
I'm very good. I'm just getting a little bit confused with the two different things that I'm supposed to be using, but hopefully this is going to work now.
Yeah, online experience is new for all of us. So thank you for joining this event in online format. And I would like to give you the word so you can start your speech.
Okay, great. Thank you very much. Okay, I'm going to put that there. Right, so good afternoon. Welcome to this presentation. We're going to be talking about local variable type inference. Is it a friend or is it a foe? And essentially what we're talking about here is that the idea of adding local variable type inference to Java. And what does it mean? Because there are some very good things that you can use it for, but there are also some things where it's not necessarily quite how you expect it to be.
Yeah, we are almost ready to get Simon back online.
Okay, so can you hear me?
Yes, we hear you.
Okay, great. So we'll start again.
Yeah, so sorry for that.
No, that's fine. Okay, right. Yes. So as I was saying, what we're going to talk about today is local variable type inference and some of the details about how you use it and the good places where you can use it, but also quite importantly, some of the situations that you need to be aware of where there are some things that might catch you out with local variable type inference. Okay, so the first thing we need to talk about is just briefly a little bit about how Java actually stores things, and specifically about the way that we use variables and how we then use those to manipulate data in our applications. So we have really two ways that we store things. So the first of those is fields, and fields are part of an object. So when we create a class, we can define fields, instance variables within that. And when we create instances of those objects, the fields are part of it. Therefore, they exist for the lifetime of an object. The important thing about these is initialization is guaranteed by the compiler, meaning that if you create a field instance of int, then it will be initialized to 0. If you create one of Boolean, it will be initialized to false. The other thing we have, which we use a lot in our methods, are local variables. And these are scoped to a region of code. So they could be scoped across the whole method. They could also be scoped within a particular statement or within a block of code, depending on how you create those variables, where you put them. That's going to determine the scope of those variables. Now, the important thing about these is because they're part of a method, they're created on the stack and they don't come with guaranteed initialization. So what you need to do in your code is to ensure that you do initialize these variables so that you don't run into problems. They are cheap, they're allocated on the stack, so that's always very good for performance. And often what we find with local variables is that the name that you use is actually more important, and how you use it is more important than the type that you've got. Okay, so in JDK 10, we had local variable type inference introduced. And the question that we really need to ask ourselves is, that was nearly 25 years after Java was first created. So why did we suddenly add the idea of local variable type inference to the Java language? And I came up with a fairly flippant answer to that, which is, well, JavaScript has got it, so it must be good. That probably isn't a good answer to this question. A better answer to this question is the fact that if you look at some of the more modern things that we have in Java, specifically around JDK 8 and the introduction of streams and Lambda expressions, what we see here is a situation where we're processing some data, but we don't actually care about the intermediate types that are being used here. So we're streaming data from an array of objects. We create a stream, then we're doing something like filtering it, then we're doing maps, then we're doing collect into a list. But we don't actually care about the fact that we've got a stream of strings, then we've got a stream of strings, and then we've got a stream of records. The intermediate types are invisible to us. We don't see those in our code. All we're interested in is the fact that we get an array list of type record at the end of that. So what we'd like to do is to extend the way that this is used into more situations where we don't care about the type. We just want to use that variable and we want to do something with it, but we're not too worried about understanding too much about the type of it. The other thing about this is it can make code more concise, but one of the very important things about making code concise is we don't want to go too far and end up with, well, Perl as a programming language. What we want is to have code that's more concise, but without losing the readability. Readability is most important because if you think about it, you're going to spend more time reading code than you are writing code. Maintenance, changes to code are much more important than the actual creation of the code in the first place. Okay, now let's look at some simple uses of local variables, the things that we would do in Java before we have type inference for them. And this is a very obvious piece of code. So we have an array list of type string, which we're going to call nameList, and then we're going to instantiate a class called ArrayList, and we're going to use a generic type parameter string to say that's the type of the array list that we want to create. Obviously, that's code that will work. Everything is great. Now, the problem with that is there's a lot of duplication in there because obviously we've got array list of type string on the left-hand side and we've got array list of type string on the right-hand side. Why do we need that information twice? If we look at Java SE 7, when we had the introduction of the diamond operator, things got slightly simpler, but not completely simple. So now we can do something like this. We can say list of type string, user list equals new array list, and we'll use the diamond operator. That will use type inference for the generic type parameter so that we know that on the left-hand side, it's a list of type string. Therefore, the array list must be of type string as well. So that's easy enough. We get the compiler to infer that, and we don't have to duplicate everything on both sides of the equals of the assignment. But obviously, that's still, still too much. We want to change that and make it better. And obviously, if we do something like taking a stream from our user list, then we have to define that the stream that we're going to create, because it's a generic class, we say stream of type string, stream equals user list.string. Great. And then we can also use local variables within constructs such as the for loop. And we can say for string name over user list and use the for each syntax. And that will obviously iterate over the user list, retrieving the names and then processing them in some way. And we can also use a local variable in a traditional for loop where we say for int I equals 0, I less than 10, I plus plus. If we look at how we can use var and local variable type inference for this, then things become simpler. In the case of our array list, what we now say is var user list equals new array list of type string. We only have to specify that we've got array list of type string once, and the compiler can look at the right-hand side of that assignment. They can say, user list has to be an array list of type string. No problem there. Inference is very simple, straightforward, and we don't have to duplicate the type within our code. Similarly, for the stream, the compiler knows that user list is an array list of type string. Therefore, the stream that we get back from that is going to be a stream of strings. So again, very simple, straightforward. We know that var, in this case, will infer a stream of type string. If we look at our for loop, then we can do the same thing there. We can say for var name over user list. The compiler will know that user list is an array list of strings. Therefore, name is going to be a string. And then lastly, we can use var within our for loop, the traditional for loop, and we say for var I equals 0, I less than 10, I plus plus. Now, this is one of those occasions where I look at that and I say to people, do not use var in this situation. And the reason I say that is because var has 3 letters. Int has 3 letters. You are saving nothing in terms of typing. There's no less code to type, but you're making it slightly harder for people to understand what's actually going on there. So in that case, I would never use var. I would always use int because it's just much clearer as to what's happening in that case. Another good example of where we can use var is to simplify our code and make things easier to read. So try with resources, a good example. What I've done here is I've created a try with resources block, and I've deliberately been fairly verbose in terms of the variable names that I've used. But you can see that if you just look at that piece of code, it's very wordy. It's very difficult to pick out exactly what's going on here. And so you've got to look through it and you've got to see, okay, I've got an input stream, get input stream. I've got input stream reader, new input stream reader from input stream, buffered reader, and it just goes on and on. So you have to look through that code quite carefully to understand what's actually happening. If we were to use var in that case, then we can tidy it up and we can make it a lot simpler and a lot easier to see what's happening there. So now we've got each one on its separate line. We can see it's input stream, get input stream reader is from the new input stream reader, buffered reader from the new buffered reader. So it's just tidying up that code, making it a little bit easier to see what's going on. So that's a good example of where we might want to use local variable type inference. Now, one of the things that we do need to understand here is that unlike in JavaScript, where, as I said, JavaScript has var, we are not changing any of the ideas behind Java from the point of view of how the language is typed. So Java is still very much a statically typed language. If we look at this example here, I've got var name equals Simon. Now, clearly, Simon is a string there, and so the compiler will infer string, and name will be set to be of type string. If I want to, I can then change that. So I could say name equals Dylan. I could assign a different string to that variable, but because the type is the same, there's no problem. The compiler will be quite happy with that. However, if I tried to do something like this, where I said name equals 42, 42 is not a string. And so the compiler will complain about that. It would say incompatible types, int cannot be converted to string. That static typing is still working. We haven't introduced any form of dynamic typing, so there isn't the ability to change the type of a variable. Once it's been defined, its type is set and it cannot be changed. Final and non-final. So in this case, what we need to understand is that var, all it does is tell the compiler to infer the type of the variable. It doesn't tell it anything in terms of whether that variable is final or non-final. And as I said, if we have something like this where we say var name equals Simon, we haven't made it final. We've simply said we've got a variable called name, assigned Simon to it, and then if we want to, we can change it later on. Name is Dylan, that's fine. If we want our variable to be final, then we still have to use the explicit modifier and say final var name equals Simon. And that way it's set, we can't change it, well, unless we use reflection. But in normal code, we wouldn't be able to change that because the value has been assigned and that's it. Some languages have an alternative to var. So rather than having final var, they have things like val or let. These are two different ways of doing the same thing. But essentially, it's the idea that you can have either a type inference, which is modifiable, or type inference, which is final. In terms of the way that this language feature was designed, the designers decided not to create a second modifier, so there wasn't the idea of val. And one of the reasons for this, one of the sort of discussions about this, was how often do you make local variables final? Because most of the time when you're using local variables, you're going to be using them to manipulate data within a method and so on. So the majority of the time, certainly when I'm writing code, I don't make my local variables final. So it makes sense to just have var. And if you really do want to make that variable final, then you add the final modifier. So that's just one thing to remember about var, is there is no val. Okay, now action at a distance. This is the idea that we need to be careful about how we use var. And so if we have a situation like this, where I define my array list of type string and I assign it to L, okay, not a particularly descriptive name for my variable, but that's okay. And then I also want a stream there, which I'm going to use, so S, again, not a very descriptive name. If I have lots of complicated code and then I use L further down, then I run into a problem, because I look at that and I go, okay, so var n equals L.get0. How do I know what the type of n is? Now, sure, if I look at that slide there and I can see all those lines of code, then it's easy for me to go, oh, L's above there, it's array list of type string, and so therefore N must be a string. Fine. But if I've got a lot of code between those, because I haven't used a very descriptive name, I've just got L, I don't know what the type of L is because I don't really know what it is, and then I get something from it, because I'm using local variable type inference and the type is not explicit there, I then have no idea of what it is. Sure, if I'm using an IDE, most of the time I can just move my mouse over N, hover it over there, and it will tell me what the type of that is. But we shouldn't rely on that. So this is one of those situations where, in this case, nothing wrong with using var for N, but what you really should be doing there is thinking to yourself, okay, if I want to be able to use L much further down, let's give it a more descriptive name, and therefore, list of names or something like that, so that I know that it's likely to be string, and therefore it's easier to understand the code. Jumping variable names. Again, this is sort of related to what we had with the try with resources block. But again, it's about sort of simplifying code out and making things easier to see what's going on. And again, what I've done here is I've used quite long type names, quite long class names, and so on. And I've got, okay, no, I've got amount increase big decimal, I've got horizontal connection, line of line, I've got constant variable, I've got a list of string. If I use var, then again, I can get a much simpler way of formatting my code, and I simply see, okay, no more jumping variable names, everything's lined up, and it's much easier to see what's going on. Another sort of simple example of where var makes some sense. Okay, now let's get into some of the sort of edge cases where things are not quite as simple as they might seem. In this case, what we've got is an array of ints. I've called it first 6 primes, and I'm assigning 6 numbers to it, 2, 3, 5, 7, 11, 13. Okay. To do that, obviously, I use the int primitive type and a set of brackets to indicate it's a one-dimensional array. What you might think to yourself is, well, okay, let's use var for that. So we'll say var first 6 primes equals 2, 3, 5, 7, 11, 13. However, that's a problem, and that won't compile. So what you'll get there is you'll get an error. It says cannot infer type for local variable first 6 primes. Array initializer needs to be explicit target type. And the reason for this is that what we've got there in the sense of the array initialization is actually in Java what's called a poly expression. So Java has 2 types of expression. There's a standalone expression, which is one where the expression the type of the expression can be determined by the expression without knowing the context in which it's being used. So all of the examples we've seen up until now are standalone expressions because we can see exactly what the type is going to be without where it's being used. The second type is a poly expression, and that's an expression which has different types depending on the context where it's used. And we're going to come back and we're going to see some other examples of this. This is a good example of that. So the problem is, you see, that in the case of our first 6 primes, yes, we could infer that it's an array of ints, but that's not the only thing that we could infer from that. We could technically infer it's an array of doubles. We could infer it's an array of integer wrapper class objects. And so that's one of the problems that we have. So the compiler at this point will reject it and say, I can't make an absolute deterministic idea of what the type is, so I won't allow that to pass. What you can do, if you really want to use var, then you can do it this way. So you can say var first 6 primes equals new int array, and then define the values that you want to put in there. So you are giving the compiler enough information to say that this is an array of ints. Similarly, you could do the same thing if you wanted to use integer wrapper classes, and you could say var first 2 primes equals new integer array 2, 3. Both of those will work because the compiler has enough information from the right-hand side to infer the type of the left-hand side. But you can't just use the array in the way that we've done above, so that won't compile. Very important, types are required on both sides. And again, so let's look at this. Var list equals null. Well, you might think to yourself, okay, well, list, I've assigned a null to that. Surely the compiler can infer from that that it's going to be, well, let's say object. Object would be the obvious choice because in terms of our class hierarchy in Java, object is the superclass of all other classes. So surely the only choice we could make there would be to make list an object, assign null to it, and that will work. Well, yes, it will, but there is a gotcha there. So the compiler will reject that. It will say, cannot infer type for local variable list. Variable initializer is null. And the reason behind this is quite subtle because, again, thinking about the type hierarchy in Java, you have object at the top and then all other classes inherit from that. Null, you might think, is just null, but it's actually not quite like that. Null is actually at the bottom of our type hierarchy. And by that, I mean that null can represent a null reference to any type of object. And by that, it means all types of objects. Because of that, the compiler will take it as a very strict interpretation of this and say, well, hang on, null could be any type of object, not just object. So in this case, it will reject it and say, no, I need more information than that. So you can't simply assign a null to it. That won't work. Similarly, you need types on both sides, meaning that you can't do this. You can't say var list without assigning something to it. And then even on the next line, you couldn't say list equals new array list of type string. Although the compiler could look at that code and say, well, yes, okay, you've defined list and then you've assigned it to an array list of type string. Technically, you would think that would work. But no, the compiler will reject that and it will say cannot use var on variable without initializer. So one of the hard and fast rule is you must initialize a variable if you're using var every time. One of the reasons for that is that if we did something like this, because we might have a situation where we say, okay, let's say list equals new array list of string, and then further down we say list equals 42. Okay, now I said earlier on that we're not introducing the idea of dynamic typing, but you could still argue that this is a feasible thing to use with Java, but then the compiler would be troubled because it wouldn't know what type to use. There could be several different things it could try and use. It could use array list of type string and ignore the 42 and generate an error. It could assign it to be an int. It could assign it to be an integer because that was the last thing that was assigned to it. Maybe you hadn't used the array list, so that would give you a working solution. Or you could just simply make it object and then use the idea of the auto boxing for 42 and create an integer object, and that would all work as well. But to make life simpler, the design says that you must assign a value to the variable when you define it. So that's what you've got to do. Literals with var. Now, this is where you do need to be very careful. So the first of these is where these are good uses of literals with var. So I've got 4 different variables here. I've got a Boolean ready. I'm assigning it to be true. A character, ch, assign it to be x. Long, sum, 0 long. I've been explicit about the value there, 0l. And string label equals foo. Fine. If I change those all to var, everything still works exactly as I would expect it to. So I can say var ready equals true. That will infer Boolean. Var ch equals x infers char. Sum equals 0l. So the compiler knows that's explicitly a long. So it will infer long, and label as a string. So it'll infer string. However, we do need to be careful when we're using numeric types. In this case, let's say I have 3 variables, byte flags, short mask, long base, and I assign values to those. If I then use those in a particular way, so let's say I'm writing information across a network and I'm relying on the size of these types in order to interpret data at the other end. So I'm writing a byte, which is 8 bits. I'm then writing a short, which is 16 bits, and then writing a long, which is 64 bits. So I can write all those, and I know that when I read the information from the other end, I'm reading 1 byte, 2 bytes, 4 bytes. If I use var, that's going to break all my code. And the reason for that is that if I look at the values I've assigned to flags, mask, and base, all of them will fit in an int. And so the compiler in this case is not going to try and infer the smallest type which will hold that value, but but it will simply say if they fit in an int and they are integer, as in not floating point numbers, I'll put them in an int. If they're bigger than an int, I'll put them in a double. But that's what's going to happen. So in that case, if you're then sending this information across your network and you're trying to read things from the other end, you try to read 1 byte, 2 bytes, 4 bytes, you're going to get all sorts of confusion there because you've got 4 bytes, 4 bytes, 4 bytes, sorry, 8 bytes for the long. So you're going to see a bit of confusion happening there. So this is one of those things that you do need to be very careful when you use var for a literal and it's a numeric value, because you might not get what you expect in terms of the inferred type. Beware of multiple type inference. Now this is an interesting thing, because what we've got here is a situation where, okay, I've created a priority queue of type integer called item q. Now I've used a diamond operator to have type inference for the type of the generic parameter. All good. So we've seen this before, we know it works. The problem is if I go through and I refactor my code and I simply say, well, okay, every time I've used a type on the left-hand side, I'll replace it with var, and that's what I'm going to do. So I end up with something like this. I say var item q equals new priority queue, diamond operator. Problem is we get double type inference. What's happening there is that we initially get type inference of the diamond operator. The compiler will look at the left-hand side and go, okay, well, I don't know what the type of that is. So in this case, the only thing that the compiler can come up with as a type for the generic parameter is object. So the primary type inference infers object for the generic type parameter. Then we have secondary type inference used for var, which will look at the right-hand side and say, oh, you've got a new priority queue of type object. That's what var will then infer item q to be. As we can see from the code above, item q needs to be a priority queue of integer, not a priority queue of object. When you try and use item q and you try and use it as a priority queue of integers, your code will not work. So this is a situation where we've got double type inference and the code is then potentially going to break. I have to say this is one situation where I think that the design of the local variable type inference didn't do the right thing. I think that at the very minimum, the compiler should issue a warning about this. And realistically, it should issue an error because it should say, I can't infer the type of this. Technically, could you be object? But in the same way we've seen other examples that get rejected, this should, I think, be rejected. And so what we need to do, as I say, is what we'll get is a priority queue of object. That's not what we want. We want a priority queue of integer. So the code will then change in terms of how it works and most likely break. Programming to an interface. Often what we do when we're writing Java code is to say, okay, we'll use polymorphism. We'll use polymorphism to say that we'll look at an object or represent an object rather than as the concrete type. We'll use an interface that then allows us to pass around different concrete types and process them in the same way. We treat them as a higher level object or high level type. Good example here. So we say list of type string is a new array list. Very common thing. Then whenever we need to pass a list around or a list of type string, we can do that. And whether we use an array list or whether we use any other form of list, then we can do that. We don't have to worry about what the concrete type is. If we use var, then var will always infer the concrete type. So var will always infer that my list, in this case, is going to be an array list of type string. People often get a little bit confused about this because then they think suddenly, oh, hang on, that's going to break my code because I'm using my list as a list of type string. And in the case of using var, suddenly it's now going to be an array list of type string and something's going to change. But if you think about it, in the first line there, it always is an array list of type string. So it hasn't changed what the actual type is. How we use it is the important thing. So wherever we use my list, polymorphism is still going to work. So although array list of type string is a list, so you can use my list wherever you need a list of type string, nothing changes. The only thing that technically would be different is that you could call methods on my list that are in array list but not in list. But if you're looking at the way that code works, then nothing is going to change, nothing is going to break, because if you're treating it as a list of type string versus an array list of type string, then everything still works. So it's very important to understand this. Using this doesn't change polymorphism. It doesn't affect the way that your code works. You can still use mylist in exactly the same way as you did before. Treat it as a list of type string, and everything works in exactly the same way. Lambdas and var. Again, what we can do is we can assign a lambda expression to a variable. And what we have to remember here is that a lambda expression is essentially the implementation of a single abstract method that's in a functional interface. So I can do something like this. I can say predicate of type string, blank line, and I can use a lambda expression, which simply says the parameter is s, and then the body of that method is return s.isBlank. I might think to myself, well, okay, I'll use var there, and I'll say var blank line equals, and my same lambda expression. That will not compile. So that will say lambda expression needs an explicit target type. Reason for that is because it's the same as the example we saw with the array before, where we have a poly expression rather than a standalone expression. This one's more obvious because if you think about this lambda expression, where you use that lambda expression, the context of it, is the important thing that determines the type of that. Clearly, the compiler could look at that code and say, well, hang on, you've got predicate of type string. That would satisfy the type of blank line, because predicate of type string has a single abstract method called test, takes an object of the type of the predicate, which in this case would be string, and it returns a Boolean. So that would satisfy that. But the problem is I can create any functional interface I like. And if I create a functional interface called foo, which happens to have a single abstract method that takes an object of the type, generic type of that, and returns a Boolean, then it will also match against the lambda expression for blank line. So we'd end up with a situation where it's ambiguous. Depending on where it's being used, could change things. Simple answer is the compiler will reject that and say you need an explicit target type. JDK 11 actually extended the syntax for local variables in terms of type inference, and specifically around lambda parameters. So what does that mean? Okay, well, if we look at this, we've got list.stream, and then we're using map, and we're using a lambda expression here, s goes to lowercase, fine. What we could do is we could do this, where we could say var s goes to lowercase. And you look at that and go, well, why would I do that? Because s is already using type inference. Lambda expressions use type inference. They know the map is taking a list of type string, and therefore the stream is of type string, so s is a string. Why would we want to put var in there since we already have type inference? And the answer is that there's only one situation where you would want to do that, and that's if you have an annotation. So you could do @not_null var s and then do it that way. Reason for that is that in order to use an annotation, you have to have a type. So it's simply a tidying up, a very minor thing. Intersection types. This is, again, one of those interesting situations where you can use local variable type inference in a slightly different way. With the introduction of generics way back in Java SE 5, we get code like this, where we can define generic type parameters, and we can say that in this case, we've got a method called getData. It's going to return something of type t, and we say that t is defined as a type which extends, well, actually implements. This is one of those things where the syntax I think is wrong. So t extends or implements both the closable interface and the iterable interface of type e. And this is something that's a little bit different to the way we have definitions already in Java. So we can extend two interfaces by using the ampersand operator to indicate both closable and iterable type e. So that returns something which implements both of those interfaces. Valid Java syntax. Okay, now if we want to use that, we might run into a problem, because let's say I've got a method called firstMatch. It takes a predicate, a condition, and then what I want to do is I want to retrieve the data that I'm going to use in terms of this first match. Problem is, what type do I use for the elements returned by getData? Because remember, this is a generic type. And that's difficult because unlike in the generic part of the code that we saw on the previous slide, where we can define that a variable implements two different interfaces, for a local variable definition, we have no way of specifying that. We could specify one interface. We could specify closable elements equals getData, or we could specify iterable elements equals getData, but we can't specify both of them at the same time. So we run into the problem that we need elements to implement closable in order to work with the try resources block, and we need elements to implement iterable of type E in order to work with the splitterator in our stream. But we got no way of defining a type simply for elements. What we end up doing is either creating an interface of our own, which extends both closable and iterable of type E, or we create a concrete class which implements both closable and iterable of type E. Neither of which is good because that's type pollution, and if we're only using this in one place, suddenly we've got a whole class or interface that we've had to create just for one particular instance. To get around that, we can use var. So yeah, XX is closable and iterable. We don't have the ability to say closable and iterable of E as the definition of the type. So the solution is var. We simply say var elements equals getData. And what will happen there is that the compiler will infer the type which is correct for something being returned from getData. So it will infer a type which implements both the closable and the iterable of type E interfaces. What this is the idea of a type which we can't actually define in Java, but we can have represented in terms of bytecodes and used by the JVM. So the technical term for it is a non-denotable type. We can't denote it in Java, but we can use it within the JVM. Another good example of that is inner classes. So this is the kind of like a bit slightly weird code. So I can create this code where I say object fruit equals new object, and then within that definition of my new object, I can actually put a field called name, apple, and I can create a method called Infrerence, which returns pom. All good. Okay, now that code on its own will compile fine, which I do find a little bit odd, but yes, it will compile. However, if I try and reference either the instance variable there or the method, that will not compile. The compiler will reject that because object doesn't have fruit, it doesn't have a name field, it doesn't have an Infrerence method. If I use var, again, the compiler can use a non-denotable type, and I can simply say var fruit equals new object, string name equals apple, string Infrerence, return pom, and then I can use those to either the instance variable or the method, and everything will work quite happily. Now, got to be absolutely honest here and say I don't think this is a good idea. I really don't think this would be great code to write because it would be confusing. But if you're determined to do that, then inner classes will work, and you can use non-denotable types. Last thing about the syntax and so on, var is a reserved type. It is not a keyword. That's very important because if it was a keyword, then what you'd actually end up with is breaking lots of code, because I'm sure many people have used var as a variable name, even though you probably shouldn't. So what you can't do in JDK 10 and later, which you could have done in JDK 9 but never would have done, is create a class called var with a lowercase v. That won't work anymore because it's a reserved type. You can still create a class called var with an uppercase v, and that will work. Which does mean as well that you can do this. You can say var equals new var. Again, I don't recommend that. That's going to be difficult to look at and go, oh, hang on, what's going on here? But you can do it if you really want to. I tried it. Just to finish off then, I've got a couple of puzzlers. Now, normally when I do this presentation in front of an audience, I can get people to put their hands up. That's not going to be possible in this situation, but I'll just go through these puzzlers, and so I'll let you think about it as I talk through them. So the first one is I've got a method here called calc1, takes an int as a mask, returns a boolean. And what I'm doing is I'm setting a temp here, which is 0x1234567 and then I do a complex bit twiddling thing where I do temp left shifted 6 bits order with temp, and it with mask, and then return whether the resulting value of that is greater than 0 or not. So my question is, should we use var here? Yes or no? Obviously, if you've got any idea about this, I'm sure you're thinking to yourself, yeah, that's probably not a good idea. And the answer is no, because 0x1234567 fits into an int. And so if we use var, as I said before, this is literals again, it'll infer an int, not a long. And the result of doing that is that if you put a mask of less than 0, that will give you different results. So using a long, so not using var, mask of less than 0 will return true. If you use var and it infers int, the mask of less than 0 will return false. So suddenly you're changing the behavior of your program. That's not a good thing to do. Second one, let's say I've got a method here called create1, takes a boolean, ticks 2 booleans and returns a list of strings. So I got list of string, new array list, if foo add list, list.add foo, if bar, list.add bar, return list. Okay, all good. And what I could do is I could change that to use var. So now I'm saying var list, if foo add foo, if bar add bar, return list. So again, should we use var here? And I'm hoping that from what I've said earlier on in the presentation, if you're on the ball, you will have spotted that you shouldn't use var here. The reason being because of multiple type inference. So I didn't change the fact that it was using the diamond operator, and I didn't put the explicit generic parameter in there. So I end up with array list of object, and you can't convert array list, can't be converted to list of type string. So a perfect example of why it really should either issue a warning or should reject that completely. Last puzzler. Okay, this is a slightly convoluted example, but let's say I've got a method called list removal, and that returns a list of integers. Great. So I create a list, a new array list, and I'm passing in some values, 1, 3, 5, 7, 9. And what I want to do is remove one of the values from there. So I'm going to use var in this case, and I use value to remove and list.remove v, and then return the list. In a different package, class, or module somewhere far, far away, I've got this method called value to remove, and it's static, integer, so it returns an integer object, and it returns 3. Now that will work. Everything will work fine. There's no problem with that at all. That code is perfect. The problem is what happens with a new intern arriving, for example, and they look at that and they go, well, hang on. Why would we return an integer object there? That doesn't make any sense. Let's return int. So I'm going to change that code. I'm going to refactor it so it returns an int rather than integer. The problem is that then results in unexpected change in behavior of your code. And the reason because of that is remove on the list interface has 2 overloaded versions. One takes an int, one takes an object. And so if you remove an element, if you remove an int, you're removing the element at the given index. If you remove the object, then you're removing the first instance of that object. So what you would see is that in the case of using var with the changed value to remove, so using int, you get 1379. And if you use it with the unchanged one, where you're using an integer object, you get 1579. So it changes the behavior of your code. Not a good idea. This is some of those subtle things that you need to be aware of. Okay, just to kind of finish off then, guidelines for the use of var. Reading code is more important than writing it. So use var where it makes sense in terms of, can you see what's going on? Is it obvious what the types are? Code should be clear from local reasoning. You shouldn't depend on the IDE to be able to find out the type of a variable. Choose variable names that give you useful information. I mean, that's just a given anyway. You should be doing that. Minimize the scope of local variables so you're not getting this long stretches of code where you suddenly start using a variable and you've got to try and figure out where it came from. Consider using var when the initializer provides sufficient information, as in you can see what the type is from the right-hand side very easily. Take care when using var with generics, and take care with using var with literals for the obvious reason that we have seen. And using var to break up changed or nested expressions can be useful, where it just makes the code easier to read. Conclusions then, basically, local variable type inference is a useful feature. I think it certainly is very powerful, but remember, with great power comes great responsibility. And consider very carefully the implications of using var in your code as to whether it actually makes sense. Does it make your code easier to read? Does it change the behavior of your code in some slightly unexpected and subtle ways? And with that, I thank you very much for listening. I'm not sure if we have the opportunity for questions. So,
Simon, thank you very much for this talk. And I will remind the participants that Simon will have the second talk as well, just in 15 minutes. And he will join the Q&A Zoom room after the second talk, because we don't have enough time right now.